Okay, welcome back, class. So we discussed about the different kind of approach that we have in NLP. Now we're going to talk about, instead of the methods, we'll talk about the approach that we use to develop an NLP application. Broadly, we can divide the approach that we use to develop an NLP application into two. The first one is, we call it a rule-based system. A rule-based system means we as a designer or as a developer, we are required to know all the rules of that language. Like if it is about morphology, we have to know what would be attached and the meaning of it. Like you have to know that och is something to be attached to the word to make it plural. You have to know that al is something to be attached, at the start of a word to make it negative, like al bellam. So al is going to be attached to the word to make it negative. So in this case, we say the rules that we are going to have would be handcrafted, which means you have to understand all the rules of the language and write it down. So develop the rules to process a different type of natural language data based on known facts. So as a designer, you have to know the facts, rules and exceptions. Mind you, exceptions are very important because in a language, we have many of them. For example, we said for Amharic, to make it plural, we are going to use watch, right? For English, we are going to, most of the time, we are going to use adding S at the end of the word. But sometimes we have IES. Sometimes the word doesn't take an S or a plural form, but still it's a plural, right? ship, we don't say ships. SHEEP, we don't say ships. The plural and the singular are the same. So this is an exception. If it is for a boy, you're going to attach S to it. So it will be boys. What about for a city? In the case of a city, then it's going to be Y is going to be changed to IES. So these are exceptions. So we are going to have such kind of exceptions. So you have to focus on known facts, rules, and exceptions. And that's what we call is a rule-based system or handcrafting. You are expected to know all the rules. The other approach that we have, which is most commonly used in natural language processing, is a machine learning approach, which means instead of you being expected to know all the rules of the language, you're going to delegate the machine to extract those patterns or to extract those knowledge or patterns from the data. But mind you, the downside of a machine learning approach is you need to have a huge amount of data to make conclusion. Okay, to make a conclusion, to make generalization, you need to provide the machine with a huge amount of data, and that's what we call is machine learning. So in a machine learning, what we have is the machine is going to capture rules. Mind you, you're not going to give it. The machine is going to capture rules. It's going to identify the patterns. So that pattern or that rule is going to come from a corpus. As we said earlier, a corpus is a huge collection of data. It's a huge collection of language data that you can use to extract pattern from. So sometimes that corpus is going to be annotated. Annotated means some piece of information about the language or its element is going to be provided, or otherwise it's going to be a clean text. So if you annotate it with the expected result, we call it the learning process is supervised. And a very simple example for that one is for supervised, you're going to have something like this. You're going to say boys, and you are going to say this is plural. You are going to say girl, and you are going to say this is singular. And you are going to have maybe here cars, and you are going to say this is plural. Somewhere else you are going to have car, and you are going to say this is singular. So by doing that, you are dictating how the machine learns. And we call such kind of learning, we call it a supervised learning, which means there is a teacher that supervises how the learning goes. The other is unsupervised. If it is unsupervised, then it means you're not going to provide it with such kind of a link, okay? You're not going to provide it with such kind of a link. You simply say, there is a word called car, cars, girl, and boys. Now from this one, if you are going to, but mind you, you have to provide it with a huge amount of data. So whenever you have this one, if you have many of such kind of thing, then the machine might say, okay, there are words that are ending with S, okay? That's what it says. There are words that would end with S, okay? So any word that ends with S is going to be considered to be a pattern. So if you have many of those, the machine would say S is something that's attached to most of the words. And that is going to give you an insight on what kind of new things to extract. And such kind of a learning process is what we call unsupervised, which means you don't dictate how the machine, captures the knowledge. But most of the time we use a combination of supervised and unsupervised learning in a single system. And we call such kind of learning system semi-supervised machine learning approach. Now we're going to talk about these 5 important kind of modelings that we have for natural language processing: state machine, formal rules, logic, probability, and machine learning. And we're going to start from the very basic one, which is a state machine. Now, what we call a state machine is, mind you, we're talking about a human language, and the human language is about sequence. When I speak, I'm actually giving you pieces of phonemes. And if you look into that, it is a sequence of phonemes or sounds. Think about a written text. It is a sequence of characters. The sequence of characters would create a word. The sequence of words would create a sentence. The sequence of sentence would create a paragraph, right? So we are talking about a sequence. But whenever you talk about a sequence, that sequence has its own rule, because things don't appear, as they wish, right? If things appear as they wish, then maybe it might not be, or it might feel odd, or it might not be understood by the receiving it. So a state machine is one of the earliest approach that we have. And the idea is, it is a formal model, it's a model. And it has a state, it has all these things, okay? It has a state, it has a transition, and it has an input. So whenever you give it an input, the input is going to pass through the states, through the transition, and tries to arrive at the end. And language is always like that. We have a starting point. We have, maybe if it is a word formation, you're going to have a character. After that character, what do you have? You have to transit to the next character. After the next one, you have to transit to the next one. And sometimes it feels odd. For example, what do you feel if you have a word of such a form? And what do you understand? It would be odd to understand this one, because you know that S can be the start of a word, then S can be followed by A, then A can be followed by S. Okay, S again can be followed by S. But when it comes to the third one, you will see that such kind of pattern has never occurred, which means that even though the same character repeats itself, the number of times it repeats itself is going to be limited. And this is the rule of the language. So we are talking about states and transition from one state to the other. And some of the transition would be challenged by the language, because the language might not allow such kind of transition from one character to the other. So when it comes to a finite state model, we can have deterministic and non-deterministic, which means deterministic means every time you give it the same input, the output is going to be the same. And if it is non-deterministic, you don't know whether the result is going to be identical for the same input that you have. This is a kind of model that we have. And we have a concept of finite state transducer, and this finite state transducer can be actually augmented with a Markov model which has a probability, because whenever you think about transition is about possibility. And the question is, which transition is the most probable? We are going to see an example, next. Now have a look at this very simple finite state model. This is a finite state transducer as an example. Now, as you can see, what we have in here, the circles are the states, and the arrows or the X are the transition. So we have the initial state and we have the final state. This is a very simple finite state transducer that is concerned about word creation in English. Mind you, it's a very small part of it. Now, as you can see, it tells you that this is the initial point or the starting point. It tells you that in this language, in this specific language, which is represented by this finite state model, a word can start either with T or with W. It cannot start with anything else, because this is what the finite, mind you, this is a rule-based system. In a rule-based system, you have to know and you have to explain the rules that you have. So for example, if I give you a word of such a form, let's say, automatically this word is not valid based on this finite state model, because this finite model, it says a word should start with either T or W. In this case, it is K. So automatically, this word cannot be covered by this finite state model. Then after that, once you start with the word either, the character T or W, the next thing is if it starts with T, then the next character that comes is A. This is a transition from one state to the other. So we are transiting from one to the other. So again, as we said earlier, if I have a word of such a form, ለምሳሌ think ብዬ ብጽፍ, this is not allowed. Even though the first character is accepted, after T, what I'm allowed to have is A. But since I have H in here, then it will say this text is not covered by the finite state model that we have in here. So as you can see in here, how many words can you generate from this finite state model? Transit ነው የምናደርገው. As you can see, we'll go this way. And until you reach this point, mind you, without reaching this point, you cannot say that I have a word. For example, what if the input is this? What if the input is this one? Mind you, it starts with T, good. The next one is A, good. The next one is L, good. But you cannot say this is a valid word, because to be a valid word, your finite state model should arrive at the final state. If it didn't reach the final state, then it means the word is not valid. So it has to start from the initial phase or the initial state, and it has to come to the final state. Now, the question that I have for you, you can text me the results. Make sure to text. How many words do we have in this finite state model? Okay, let's see how many results that we have. Abraham said 12, Barnabas 7, Tamasgan 8, Getaw 5, Getachew, I think Getachew 3. Then what do we have? Andamlak 7, Daraje 2. Okay, Kadist Sost 2, Sost. Okay. But let's see. Okay, thank you very much. Let's see together, and you'll see what we have. Now let's go through the first one. So let me start from here. Okay, then I'll go this way. Okay, okay. Then I'll take this one, and I'll come here. So what do I have here? T, A, L, K. So it means the first one is, the first word that I have is talk. So let's have it here. The first word is talk. The second one, let's follow the same path. Okay, let's follow the same path. Okay, let me see if I can clear it first. Let's clear everything first. Okay, then the first one is this. Okay, so I'm going to arrive here. As you can see, the characters that I have is T-A-L-K, and this is nothing, nil. And it tells you that this is a base 4, which is talk. Let's take another pass. Let's come the same way, okay? Yeah, this is the first one. Let's let's take the same pass. But instead of going up, what if I go this way? And as what if I go this way? Then it means it would be talks, T-A-L-K and S. And it tells you that this is the word in third person singular form, right? He talks, she talks, and that's what it means. So this is the second word. Then what if I follow the third path? It's going to be talking. What if I follow the fourth path? It's going to be talked, which is in a past tense form. So it tells you that whenever you attach ed to it, it is a past tense form. Whenever you attach ing to it, it is a progressive form. Whenever you attach s to it, it is third person singular. And if you don't attach anything to it, it is a base form. But mind you, this is only for talk. So we have 4 words, which is talk, talks, talking, and talked. What about if I start with W? It will be W-A-L-K, which is walk. Then I have the base form. I have the third person singular form. I have the progressive, and I have the past tense. What if instead of going to A, what if I go to O? So it's going to be again this way. It's going to be work. If I go to the first line here, it would be the base form. If I go to the second, it means it would be works, then working, then worked. So it means we are going to have a total of 12 words from this one. And this is what we call is a finite state. But mind you, to develop such kind of a model, mind you, we can't imagine how complex it would be for a Maharic. So if you want to develop a finite state model, then you have to know how the characters belong to one another. For example, as we said earlier, you might not have more than 2 duplicate characters, right? ብዙ ቦታ ላይ እንደዛ ነው ያለን. So for example, you cannot have such kind of a word. ለምሳሌ እንደዚህ ልል እችላለሁ. Let's say kindness ልል እችላለሁ, which means K ይጀምራል, I would be followed, N, D, then ተመልሶ N ላይ ይመጣል, then E, then S ተመልሶ ላይ ይመጣል ማለት ነው. But I cannot have this. This is not allowed. The language doesn't allow me to have more than 2 S's adjacent to one another. And this is a rule that you have to understand. And in a finite state model, you are expected to come up with such kind of a model. So this is what we have. A finite state model can be used for 2 things. You can use it for generation. Generation means producing a word, or you can use it for analysis. Analysis means once a word is given to you, you can actually understand what is inside of it. So when it comes to generation, this is what it means. What if I give you the word work and I want you to make it into 3rd person singular? This is a question, mind you. This is what we mean by generation. I give you the base form. This is a base form. And I will give you the change that I want to happen to this one. So I give you the word work and I want you to make it to 3rd person singular. It's just like I give you a word and make it plural. I give you a word and make it a past tense in the middle. So in this case, this is what we do. So the input is W. So the input is W. So W is going to be, again, the output because that's what I want. O is going to be the input. Again, O is going to be the output. R is going to be the input. And again, R is going to be the output. K is going to be the input. And K is going to be the output. Then after that, what do I need? I want to find 3rd person singular. So what does it mean? In the next step, I'm looking for 3rd person singular. ስለዚህ የመጀመሪያው ላይ ስመጣ it is a base form. መጨረሻው ላይ ስመጣ it is a past tense. መሃል ላይ ስመጣ it's a progressive. The one that I have as a 3rd person singular is the second one. ስለዚህ ምን እላለሁ? Instead of the 3rd person singular, what do I use? I'm going to use the replacement. Mind you, ምን እየሰራ ነው የመጣ ነው? W ሲሰጠኝ W, O ሲሰጠኝ O, R ሲሰጠኝ R, K ሲሰጠኝ K ነው አይደል የተቀበልኩት? 3rd person singular ሲሰጠኝ ደግሞ I'm going to give it S. So ምን ሆነ ማለት ነው? The word is going to be produced and I'll say this is works. And this, I know that it is in a 3rd person singular form because of the information or the morphological information that I have in here. And this is what we call is generation, which means I'll give you a word and I will ask you to make it plural. ለምሳሌ ምን እላለሁ? በር ላና plural አድርጉት ስላችሁ ምንድን ነው የምታደርጉት? ይህን finite state model ትከተሉና you have to make sure that እላዩ ላይ ዎች መጨመር አለበት so that በሮች እንዲሆን ወይንም ዎች መጨመር አለበት ማለት ነው. And this is what we do in generation. In analysis, it is a reverse action, which means I will give you the complete word and I want you to tell me its properties. And that's what we call analysis. So in this case, you will give me T and I will give you T as an output. You will give me A, I will give you A as an output. You will give me L, I will give you L as an output. You will give me K and I will give you K as an output. Kazas voila. Then the next thing that I have is ED. So from the 4 passes that we have in here, I'm going to look for the one which has E as an output. ስለዚህ እዚህ ላይ ስናየው output is nil, the output is S, the output is I. But this one, the output is E. So it means I'm going to follow this path ማለት ነው. እንደዚህ መጣና I'm going to follow this path ማለት ነው. Because this is the place where the input is the same as the output. Then D ነው ያለው. D ስንሰጠው ግን ባዶ ነው የሚሰጠኝ. But when you provide it with E, it has already given you the past. So what do you say? It means it is a word talk in a past tense form. And this is what we call is analysis. It analyzed the word. So a finite state model can be used for these 2 things, okay? For 2 things. One, if I give you talked, it will say talk and past tense. Or if I give you talk and past tense, it will give me talked. So in CINEMATA, this is what we call its generation. From a word and a part of speech, it gives you the actual word. From the word demo, it will give you the analysis. It gives you the grammatical feature. And this is what we call is the analysis and generation using a finite state model. So this would be a cues for you. This is a finite state model. This is a starting point. Okay, this is a starting point. Point. And as you can see, this is the end. Now try to generate 8 possible sequences from this one, okay? Try to generate 8 possible sequences from this finite state model. This is your first quiz. The next quiz that you have, this is something that you are going to submit. ከአርብ በፊት ሐሙስ ዕለት ሰብሚት የምታደርጉት ይሆናል ማለት ነው። በኢሜል ነው ሰብሚት የምታደርጉልኝ። Okay? You have to submit this one via email. I think you already have my email. ከሌላችሁ ግን እዚህ ጋር ጽፍላችኋለሁ። Okay? I think it's better to send it to this one. wendemule@yahoo.com. Make sure to submit it using this email. wondemule@yahoo.com. Now the question is, let's assume that you have these Amharic words, okay? You have these Amharic words. Now develop a finite state model that would generate all these words. Mind you, are going to develop one finite state model that can accommodate all these words, okay? This will be your assignment. I'm going to post the same thing on our Telegram channel so that you will be reminded of the assignment, okay? Now, that is the first one, mind you, finite state model. The next kind of approach that we have is a formal rule system. A formal rule system is concerned about the rules of the language, which you cannot learn using a pattern. Like regular grammars. Grammar is about word order. Word order need to be modeled using a formal rule system. Regular relation, context-free grammar about a syntax, they have to be represented, or there must be a mechanism to represent those rules. So when it comes to phonology, morphology, and syntax, we are going to rely more on formal rule systems. So in that formal rule systems, our job is going to be most of the time searching through the available space. For example, if it is about phonology, you're going to search through the sequence of sounds. It's about morphology, you're going to look for or search within a sequence of morphemes that you have in a language. So most of the time we are going to use a searching method because we are trying to come up with the formal rules from the linguistic element. The other type of approach that we have is logic. Logic is about relationship, mind you. Logic is about why do you say that this is a wrong sentence? Okay? If I say the stone read the book. If I write this one, why do you say this is wrong? You're going to say this is wrong because you know that a stone is not capable of reading. And this is a logic. It's not about what we call syntax. Because as a syntax, we know that a stone, like you can say the boy read the book. You can say this. This is correct, right? But mind you, a stone is a noun, boy is a noun. So why do you say that boy is correct and the stone is not correct? It's only because that a stone is not an object that can perform the action of reading, whereas boy can do that. And this is basically what we mean by a logical relationship between the words. So logic is going to be like first order logic, feature structure, semantic networks, and conceptual dependency is what we use to study meanings in a language. So logic is going to be the one that we use to model, as we said earlier, we are going to use it most of the time to model semantics, which is about meaning, pragmatics, and discourse. The other type of approach that we have is a probabilistic approach. Probabilistic approach is concerned about the likelihood of some construct happening or being related to one another. So whether it's in a finite state machine or in a formal rule system or in a logic, probability can be highly used. And probability is very important whenever you want to deal with ambiguity. Ambiguity means a certain construct having multiple meanings, or a certain construct can have multiple interpretation. And during this time, it's only what we call a method of probability or probabilistic approach that will give you a solution. Like, for example, if you say, if you find the word book, it can be a noun or it can be a verb. If it is the written material, it is a noun. If it is the action of reserving, then it's going to be a verb. But which one do you mean? So the idea is you're going to have a choice. Like, if the word book appears in a text 100 times, and if 80 of the times from those 100 instances, if it is tagged as a noun, and in the remaining 20 instances, if it was tagged as a verb, then you might say, whenever you find it, if you say it's a noun, then you are going to have a greater chance of being correct than calling it a verb. And this is very important. So probability is about occurrence. So it's very important to use probability not only in such kind of finite state model or formal rule system, but it is very important to use it in a machine learning approach. So machine learning approach, as I have said earlier, is most of the time what we use in natural language processing. And the idea in machine learning approach is to automatically learn from examples. And that's what we want to do. We want to learn from examples, okay? Examples are, of a huge amount. So the system can be trained on a large corpora. Mind you, a large corpora means a huge collection of language data. And from that one, we can actually model a pattern. And that is the approach of machine learning that we have in computational linguistics. So I'll give you only this example and we will be done with this topic. We will be done with,
Hello.
Yes?
Hello.
Yes? Any question? Okay. So
Hello.
the idea that we have in here is we are concerned about,
Hello.
yes? Any question? Okay. The idea that we have in here is how do you judge if something is intelligent? That's what happening in our mind, right? For this one, we have the Turing test. The Turing test, the idea which was done in 1950, the idea is how can we judge whether a machine or a program is intelligent or not? And for that, Alan Turing came up with a test. And that test is like, if a machine can win a game, then you can judge it to be intelligent. You can say that it has some understanding, it has some thought. So the idea in the Turing test is this one. How can we measure the intelligence of a machine? So the Turing test is a machine can be accepted to be intelligent if it can fool a human being, okay? If you interact with the machine and if you are fooled in a way that you think the machine is a human being, then it means the machine is intelligent. And for that, in 1966, there is a system called, Lisa or Elsa, which acts as a psychiatrist. And what it does is, mind you, we don't have a speech system at that time. You are going to, have a teletyping, which means you are going to type to interact with the machine. And this is what happened. In that system, this is what happened. The user says, you are like, my father in some ways. Then the machine, this intelligent machine says, what resemblance do you see? Mind you, this is a technical thing. To give such kind of a response by the machine needs to analyze the input provided by the user. So as you can see, the input is, you are like my father in some ways. So what it does is, from this text, it's going to pick some of the words that would lead to the next question. Like my father, Milono said. So the next question is, if this person is talking about somebody being, like someone else, then the next question can safely be, what resemblance do you see? So mind you, whenever this, result is received by the human being, the user said, you are not very aggressive, but I think you don't want me to notice. This is, the person writing this text. Then the machine says, it's going to, again, from this text, it's going to pick some of the words that would lead to the next question. Mind you, it's not going to pick the word I, it's not going to pick the word to, it's not going to pick the word that. It will pick a word. Mind you, this is an NLP application that will lead to the next one. And what it picked is the word or the phrase, you are not aggressive. So the system will say, what makes you think I'm not aggressive? Mind you, it's a leading question. It is as if the machine is understanding the person, but mind you, the machine is speaking relevant words from the previous conversation so that it would lead to the next one. Then it say, you don't argue with me. Mind you, at this point, again, it picks the word don't argue with me. And it will say, why do you think I don't argue with you? Then it says, you are afraid of me. You know, the person says you are afraid of me. Then the machine says, does it please you to believe that I am afraid of you? Mind you, it's a language game. And in such kind of conversation, if the person, you know, stays with the system for a longer time, it's only because that person thinks he's talking to a psychiatrist. And in this way, you can say the machine is intelligent because it fools a human being as being, you know, a machine. So this is a method how it works. What it does is it would find a term that can trigger the next input the next output. So from the input, it will pick a term. Mind you, picking a word means you have to know what kind of words to pick. And that's an NLP task. So that it will trigger the next one. Then invoke a possible candidate pattern. Maybe, am I talking about a family or a mother? No, you have to pick something which will lead you to the next one. Then compose a sentence based on the previous trigger. Then try to give it a pattern. Mind you, in such kind of system, if the machine is confused, the machine will say, can you explain? Would you repeat that? What do you mean by that? Which are very generic questions. But mind you, that person, if that person is fooled, then it means the machine is intelligent. So this is how we judge a machine is intelligent, but in NLP application, we have even more than this concept. So in NLP, this is what we have. We have seen it like question answering, text categorization, text mining, machine-assisted translation, language learning, and spelling correction. All these are NLP applications that we have. But mind you, in this application area, all these are possibilities like natural language dialogue system. We have talked about them. Document image analysis, text proofreading, machine translation, storytelling. All these are relevant NLP applications that we have. Then the last point that we have for today is this one. Why is it challenging? The first thing is language is about words, rules, and exceptions, and they are always difficult. The other is ambiguity appears at all levels, mind you, ambiguity at a word level, at a phrase level, at a sentence level. And we have many different languages to deal with. In Ethiopia, we have like, more than 80 languages, so you have to deal with that. And language has a cultural element which is very difficult to capture by a machine. And language are not equivalent in the expression, mind you, even though languages are equal, but in terms of their expression, they are not equal because some language, they use a single word to express a huge thing. Like, በእንግሊዝኛ said, we know that it is many words, right? Both are expressing the same concept, but they are not equally expressive. We have all are systematic, but not, can easily be captured by a machine. It keeps changing. We have new words, new rules, new exceptions. And it can be at electronic level, it can be a speech, it can be noisy. But we know that even though it is very simple for a human being, it's a big deal for a computer. And we are going to see this throughout the chapter.